This is Marcus Tillmon giving a video on integer division. Here's the definition given by the book. When both operands of a division statement are integers, the statement will result in integer division. This means the result will be an integer as well. What does this mean? When dividing integers, or numbers of any type, it's important to divide by at least one number of the data type you require. This is especially important when dividing to get accurate decimal points, which we'll have an example of on the next slide.
Here we have our integer division demonstration. Right here we have public class integer division. I just named this file that. And public static void main string args. This is regular syntax, always required, never forget it. And here we have double parts. Double parts is a variable of the type double that is normally reserved and used for decimal type variables. And here we're going to try to set parts as a number. Parts equals 17 divided by 3. Now, the problem here is both 17 and 3 are integers, just regular integers, meaning they don't have any trailing decimals. So we're going to end up without the proper output below. So we have the print statement, and we have parts here. And the actual output for this operation is 5.0, which is, as you know, incorrect because 17 divided by 3 should be 5.666, trailing decimal sequence till 7. And this is not acceptable when using a variable type double. So in order to get the proper value, we come down and we have parts equals 17 divided by 3.0. And now we're having an int divided by a double, like a double integer. Well, a double. So long as one or both of these types in the operation is of the proper type. So like, see, we have not a decimal, and we're trying to get a decimal. We'll get the proper output. So here we have 17 divided by 3.0, proper output statement plus parts. And now our output is finally 5.6666, trailing decimal sequence till 7.
Here are some helpful hints when dividing integers. If possible, always use a variable with the appropriate data type when dividing. For example, here we have double variables A, B, and C. So 3 variables by the type double. We have B equals 5 and C equals 2. And A here equals B divided by C. Because both 5 and 2 are doubles, even though you can't see it here, they both have 0.0 on the end of them, which ends up being 5.0 divided by 2.0. And with that being that way, we have A equals 2.5 because at least one of the integers that was divided in the statement was a double data type, which fed in a double back into the original variable. Float can also be used in place of double. Here are more helpful hints when dealing with integer division. Here we have conversion using cast operators. Cast operators let you manually convert a value, even if it means that an error conversion will take place, as we'll see later. Cast operators are normally two parentheses that have a data type in between them and are placed immediately next to the variable for conversion. For instance, here at the bottom, we have integer represented by int between two parentheses immediately next to an x, a variable x, followed by a semicolon. More examples include x equals long 3.7. This will cause x to be 3 because long is almost analogous to integer data type, which doesn't have decimals. And then down here we have number equals int 72.567. This causes number to be 72 through the above method.
Here's a demonstration of cast operators and a few helpful hints. Alright, once again we have parts from earlier in the video, and now I'm trying to set it from a division of A divided by B, which is A equals 17, B equals 3. Now, as you can see, both of these are ints, which would normally cause the same problem that we had before with the improper output. However, we're using a cast operator of double to change 17 into a double. And cast operator is simply two parentheses with the data type in the middle, and put it next to the variable or number immediately next to the one you want to change. Now, once we print out proper output, as you can see, even putting the cast operator double here next to A still gives us 17.0, which still gives us the proper decimal that we need. And when dividing, remember that if you're and when dividing this type, since we're trying to get a double, at least one of these variables needs to be a double in order to get the proper output. And since A, 17, is a double, lo and behold, we get our same proper value. And that's using cast operators.
This is Marcus Tillmon with Integrated Division signing off. Hope you learned a lot from the video. Bye bye.